All right, welcome. I'm going to be going through some Unit 16 Day 5 notes. At the beginning of this, numbers 1 through 6, I would highly recommend that you try factoring these first and double checking them. I am going to be kind of running through them pretty quickly, so try them on your own. Again, you want to factor as completely as possible, so you want to look for anything any type of factoring that you can do. GCF, grouping, put them together. If there's more than one time you can factor stuff, but definitely pause it and come back to this or speed the video up so you can get to that point. Okay, the 4 here, so you're grouping, taking a 3 out here, so you're grouping. There's a 3 there. Got the same parentheses, so we got 3n minus 4, and then I get n squared plus 3. Again, you have a GCF, the numbers are just bigger. So we're looking at 2 at a time, these 2, and then these 2. Biggest one is 9x squared, so I get 7x plus 6. I know I figured out I can take 16 out, so I have 7x plus 6, which is great. I got 7x plus 6 in both. And now I have 9x squared minus 16. Now, here is one of these things where I say grouping. It's great. You get to these 2 parentheses. But this is, you can factor more. Okay, completely means you do as much as possible. So this first parenthesis stays like it is. This is one of those ones that comes into 2 square roots, a subtraction in between. Split 9 up to 3 and 3. I got x and x. I got 16 is 4 and 4. One's positive, one's negative. It doesn't matter which parenthesis gets the positive and which gets the negative. Okay, so yes, I would be looking for that whole thing factor as completely as possible. Number 3 is the same kind of thing. Perfect squares, split them up. 25 is 5 and 5. X and X. 36 is 6 and 6. One positive, one negative. This is a big one, but it's the same idea. We got X and X. So you know what? I switched these around. This should have been 18. I inadvertently switched the digits around. So it'd be 9 and 9. 4 and 4. One negative, one positive. Now the thing is, again, we have this. No, we don't. We're just going to leave it like that. Sorry for the pauses. This is as much as you can do. Number 5. Not quite sure what to do. You can multiply these together. Multiply 2 numbers and multiply to negative 65. And they add to negative 8. Okay, the numbers are 13 and 5. But one is a negative, and negative 13 plus 5 is negative 8. If you wanted to do grouping, you are welcome to. Or since this is a 1 in front, we literally can just go to the 2 parentheses and x minus 13, x plus 5. Sorry, even on these problems, grouping will work. If you wanted to split this into negative 13x plus 5x, you are welcome to, and then you can take 2 at a time like you did on the first one. Okay, I know there's lots of different rules for factoring and trying to make it as concise as I can, but there's just different things going on to make them factorable and different things trying to look for. On this one, there's a GCF x squared plus 16x minus 3. And now we got to continue factoring the inside to see what we can do. All right, so I'm going to multiply those two things, the first and the last. So I'm going to multiply two numbers that multiply to negative 36, but they're going to add up to 16. That's going to be negative 18 and 2. And how am I getting these numbers? I'm practicing a long time. Negative 18 here. To double check stuff. So if you're working through them, you're like, that was really fast. It's not that I just did it really fast. I have been working on it. All right. So I'm going to split up my 16x to negative 18x plus 2x. All right, and then I take 2 at a time. Oops. Got 6x here, and I got 2x minus 3. Sorry. I got a 2x minus 3 already here. I'm going to keep that in parentheses. And now, if there isn't a number sitting there, we use it as a 1. So I get 2x minus 3 times 6x plus 1. And of course, I don't want to forget about my GCF sitting out there. It does need to be part of the final answer. That is factoring as much as possible. All right, there's some factoring problems. On Friday, there's going to be a review. The next thing goes into the long division or the area model. I'm going to do long division here. If you are doing the area model, it's just you should end up with the same answer. And if you want help working through it again, no problem. So again, I would suggest pausing the video. I'm going to try to go kind of quickly, not to make this video too long. All right, because I know there is more stuff. Or x to the third minus 5x squared plus 3x minus 20. All right, so good. Focus on these two. So to get x squared to be a 2, I multiply by 2. And then you do another x squared, and I multiply everything here. So I get 2x to the 4th plus 4x to the 3rd minus 6x squared. Put in parentheses and subtract. Okay, nicely enough, these cancel out. These also cancel out. Negative 5 subtract negative 6 is positive 1x. 3x and minus 20. All right, nice that a couple things canceled out there. All right. So next thing I want to do is how to multiply x squared to get 1x squared. And nicely enough, that's 1. Multiply everything here. Whoop. X squared plus 2x minus 3. Subtract, those go away. 3x minus 2x is 1x, or just x. And negative 20 minus negative 3 is minus 17. Now, when I look at this, I'm looking at my first term here. This is technically an exponent of 1 here. It is less than what's sitting here as the exponent of 2. So I know I don't need to go on further, and this is my remainder, this whole thing. All right, so when I divide this out, I have 2x squared plus 1 plus x minus 17 over x squared plus 2x minus 3. Okay, yes, I am looking for this whole answer to come out when you divide it to figure out what the polynomials is at the end, and that is it. All right, and number 8, same idea. You can do long division on this. This one, you know what, I'll do the area model on. Okay, if you want to do long division, absolutely go for it. Do long division. Just make sure our answers end up matching in the end. All right, so I have an x and a 2 here. This first term is what I put here. All right, and then I think, what do I multiply x by to get 3x squared? So 3x here. And then multiply it times the 3x times the 2, so length times width to get 6x. I'm missing something. All right. Yes, I am. This is a third. All right, sorry. So this should be 3x squared. There we go. All right, so this should be 6x squared. Now, if I combine diagonally, I got 6x squared, and I want to end up with 8x squared. So I put a 2x squared here. Now I think, I have x again. What do I multiply to get 2x squared? So that's plus 2x. Multiply length times width to get 4x there. Go diagonally, say, now I want to get 5x. So I have 1x here. Okay, so I multiply by positive 1 here, and I get a 2. All right, but my last thing here is a 2, but I really want to end up with negative 7. So this is a remainder of negative 9. Okay, so what you end up with is what's along the top and the remainder. Okay, so when I divide these, I get 3x to the third plus 2x squared plus x plus negative 9 over x divided by x plus 2. Okay, so this is the answer I'd be looking for. All right, I mentioned last time that there's going to be one more method to doing division, and it is called synthetic division. And you can only use this when the divisor is linear, meaning something like x plus 2. You can have 3x plus 7, really, if you wanted. But we can't do this. You cannot do synthetic with anything x cubed. You cannot do it with anything x squared. You cannot do anything like x to the 5th minus 1. There has to be a singular x, a linear one, to be able to do synthetic division. Now, I'm going to use the problem up above from number 8. That's what I wrote here again. You'll see it's the same problem, but I'm going to show you synthetic division. What you have now, right now, this x plus 2, anytime you do this is called a factor. What you want to use is a 0. So you set it equal to 0. You're trying to figure out, what number would give me 0? So you subtract 2. Okay, so we use the number negative 2. So I don't use positive 2, I use a negative 2. This synthetic division, it gets rid of some of the x's initially. And I use kind of an upside down box compared to what I did with long division. So I put this number, negative 2, sitting right outside here. And now, inside the box, I'm going to have like 2 rows, a top row and a bottom row. So I'm going to put stuff on the top row here. And what you do is you take the numbers, the coefficients, they're called positive and negative. And instead of writing 3x to the third, we only use that 3, so we write 3. Now we make sure our exponents go down in order. This is 8x squared is next, so I write 8. And then I write 5 for just x and negative 7 for the remainder. Now, you have the setup here. I'm going to divide by a negative 2. Our factor is x plus 2, so I'm going to use a negative 2 for x. What happens is, it's a little bit shorter process. That first number, you just bring it down and say, okay, this is a 3. Now you multiply this 3 with a negative 2 and write it under the next digit. Okay, so 3 times negative 2 is negative 6. And now you add them together. So I'd get 2, and then you repeat it. 2 times negative 2. You put it under the next one. It's negative 4. Then you add them up. And you keep repeating it until you run out of numbers. This is 1. Multiply the 1 and then negative 2 and get negative 2. And then we end up with a negative 9 at the end. Now, you'll start seeing, if you look up here, in our problem above, remember, these two are the same. I had negative 9 here at the end. I have a 3 in the beginning, I have a 2, and I have an x. Well, I almost have this here. So on this is the remainder. The number at the end is the remainder. Now, initially, when you do this is 3x to the third when we started. When you do synthetic division, you are working now with the numbers down here. You always decrease the exponent by 1. So if this started with x to the third, this is now x squared. And it was x squared, so now this is x. This is a constant, so our answer is 3x squared plus 2x x plus 1 plus the remainder of negative 9 over our factor of x plus 2, whatever we divided by. And you'll see that that matches the answer above. Now again, you can only do this if it's a linear, so the next one, yes, it's linear. Okay, you can do synthetic division if you don't want to mess with it. If you just want to do long division or the box, you are welcome to do that as well. This is not a must. This is, hey, this is out there for you. If you want this, you set it equal to 0, so you get x equals 5. Okay, I bring these numbers down. I bring it down as a 1. And I always have to make sure I'm going down in order by my exponents. Okay, first thing, you bring down the 1. You multiply it with the 5, write it under the negative 2. Add them up. Multiply that with the 5, write it under the negative 16. Add them up. Multiply that with the 5 again. You get negative 5. So you get a 0. Now this is a special situation. There is no remainder. Okay, there's no remainder. So this means a lot of different things actually. When x is equal to 5 in this, x minus 5 is a factor because it is a nice factor. We get a remainder of 0. It is a factor that goes into it evenly. There's no remainder because there is no remainder. Oh, wait. No remainder. This means x equals 5, or 5 is a factor. Sorry, this doesn't make sense, does it? Oop. factor, x equals 5 is a 0, a solution, or root. And it just is a different situation. We're going to deal with stuff coming up with this in the next half of the unit. Oh, one thing I didn't get back to today. My final answer. All right. We got these x's here. So this started off as x to the third. So this is now going to be x squared. And this is just x. And this is just our constant. So our answer is x to the second plus 3x minus 1. Now the next one, same idea. Find the quotient, whatever we divide by, the divisor. We solve for x, so it's going to be equal to 0. Now this is one of these ones you have to be very careful of. There are placeholders needed. There are 2x to the 4s. But there are 0x cubes, so I need to put a 0 in there for x to the third. X squared is negative 20, negative 6, and then 7. They need to go, exponents go down in order. There's x to the fourth, x to the third, x squared. They need to go down in order to be able to come out correctly with this. So it's just 2, multiply with negative 3, write it down. Add them up. Multiply it with negative 3. Write it under negative 20. Add them up. Multiply it with negative 3. You get 6. Add them up. Number at the end. This is our remainder. And started off as x to the 4th, so this is 2x to the third. Minus 6x squared minus 2x. You can write plus 0 if you want, but 0 doesn't really do anything. There's 7 over x plus 3. All right, there's synthetic. So the next ones you want to do is x minus 5 a factor, meaning does it have a remainder equal to 0? That's what you're looking for, a nice factor that has a remainder of 0. And you can do this x minus 5. You can do synthetic if you want. You can do long division if you want. negative 11, negative 10, 75. First number down, multiply. Add them up. Multiply. Add them up. Multiply. Add them up. Yes, x minus 5 is a factor. All right, the continue to factor part means put the x's back in. So this is 2x to the second minus x minus 15. And do some factoring for these. All right, so multiply to negative 30, add to negative 1, negative 6 and 5, 6x plus 5x. X minus 3. Times 2x plus 5. And of course, if we have factors, we want to write all of them down here. So we have x minus 5 as well. Now, on the next one, as you're going towards it, is this a factor? Again, it's linear. You can set equal to 0. 6 over 4, which is equal to 1.5, or 3 halves. It is still linear, so you are perfectly welcome to work with it. I get 4x to the 4th, negative 6x to the 3rd, 0x squared. So I need that placeholder. It's 12. All right, bring the first one down. Multiply. Add them up. Multiply. Add them up. Multiply. That's kind of nice, huh? Add them up. And then multiply. And then add them up. Okay. All right, 4x minus 6 is not a factor because the remainder is not 0. All right, I do suggest you try this next one. This cannot be done with synthetic. It does have to be long division. I'm going to write it out there. There's a lot of factoring involved, so see what you can do. Double check your answer, and we'll talk to you later. Let me know if you have questions. Send a GChat or email.